Hello and welcome to this video on the multiplier. The circular flow of income model allows us to explain changes in national income, and we do this by looking at the flow of money around the economy between firms and households. So for example, when firms produce goods and services for households to consume, money flows from households to firms. And in return, firms eventually distribute that money through income or rent or wages or dividends back to households. And GDP is equivalent to national income in this model. Now, sometimes money might leak or be withdrawn from the economy through savings, tax, or imports, and sometimes money might be injected into this system through exports, government spending, or investment. And we can use this model to better understand what might happen given changes in our economy. So for example, if there was an increased investment by businesses of £200 million, we can use that to predict what would be the impact on GDP and use language to explain that. So for example, in this situation, an increase in investment by businesses of £200 by taking out loans from banks would be an injection into the circular flow of income of £200 million. Now, what impact would that have on GDP? Well, if £200 million more is being spent within our economy, GDP or national income would increase by 200 million. However, some of you might be thinking, what then happens to that 200 million? If that 200 million is then earned by firms and redistributed to households, then those households might well spend some of that 200 million again on more goods and services. So actually the increase in GDP might be more than 200 million. In fact, it might be multiplied by a greater amount because of the nature of the flows around the economy. And that's what we're going to look in this video, how increases in GDP may be more than just the initial investment due to this multiplier effect. So our objectives for this video, to understand what is meant by the multiplier and the multiplier process, including the multiplier ratio, understand marginal propensities and their effect on the multiplier, and then finally there are some calculations that we need to be able to perform to work out the multiplier effect. So let's have a look at the multiplier principle. So we said initially that we had an injection of business investment in our previous example. Let's imagine our initial injection of investment is £100 million. That's the initial injection. So an injection of £100 million would increase GDP by £100 million. Okay. So the initial injection of £100 million, GDP increases by £100 million. But let's then think what happens to that £100 million. That £100 million is being earned by firms, and eventually that will circulate back to households. So eventually households are going to receive that £100 million in the form of wages or profits or dividends. So what happens then? Well, let's imagine that households save 20% of income and consume the rest. So what's going to happen now? Households are going to save 20% of the 100 million. So if we move now onto the green arrows and lines, they're going to save £20 million. That's 20% of 100 million, and they're going to spend the rest. So how much would they be spending? They would be spending 80 million. So now we have a second increase in GDP. Beyond the first 100 million, we now have another increase of 80 million. So GDP is going to increase by a further 80 million. But this is circular. What's going to happen? That 80 million is spent in firms, and eventually that 80 million will find its way from firms through wages and dividends and profits back into households again. Now, if households save 20% of their income, they're going to now save 20% of 80 million, which is 16 million. So they're going to save 16 million, but spend the rest, which is 64 million. So we have, again, a further increase in GDP. So this initial injection of £100 million has actually led to a total GDP increase, assuming the money flows round twice, of £244 million. So from an injection of £100 million, we have an increase in GDP that is now 2.4 times bigger than the initial injection. And we call this the multiplier effect. When you inject money into the economy, because of the nature of flows of money and income around the economy, that initial injection is normally magnified into greater spending on GDP, on goods and services produced. And the extent to which that happens is determined by the multiplier ratio. So the multiplier ratio is the rate of change in national output or national income compared to the injection that caused it. So what we're saying is if there's an increase in government spending, how much would be the final increase in GDP? So if we take the injection into the circular flow and times it by the multiplier ratio, we would get the final change in GDP. Let's have a quick look at a couple of examples of this effect. So let's imagine the government injects £200 million in a project to build thousands of new affordable houses. That money is then earned by firms and redistributed to households through wages and profits, and that money is then further spent by households. So we have a larger increase in GDP than just 200 million. If the final rise in GDP was 300 million, then we're saying the value of the multiplier within our economy is 1.5. There's been a 1.5 times bigger increase in GDP than the initial injection. 200 times 1.5 gives us 300. If the final rise in GDP was only 250 million, then the value of the multiplier would be 1.25. 200 million pounds injection times 1.25 gives us the final rise in GDP of 250 million pounds. The multiplier effect can be both positive and negative. A positive multiplier is when an initial increase in an injection leads to a greater final increase in real GDP. A negative multiplier is when an initial decrease in an injection, if we reduce the amount of money being injected in the economy, it leads to a greater reduction or decrease in real GDP. So remembering that a decrease in an injection can cause a fall in GDP, and if there is a negative multiplier effect, the fall in GDP will be greater than the decrease in the injection. Now we need to be able to explain the process. So what's going on here? What is the multiplier effect process? So again, if we look at our government house building program here of £200 million, what are the steps involved? Well, a new house building project injects £200 million of extra demand and output into the economy. Many businesses benefit directly, including building supply industries, architects, etc., all the firms that would be required to build those houses. And the money that those firms receive will generate new flow of factor incomes as those supply industries and architectural firms pay wages and profits back to households. Now, the extra income that those households have earned, the big question is, will that stay inside the circular flow of income, or actually will it be saved or paid out in tax or paid on imports? What will households and businesses do with it? That's the key question. If it does stay inside the circular flow of income and they spend a lot, they have a high propensity or high rate of consumption, then the multiplier effect is likely to be quite strong and the impact on GDP quite large. So we've looked at what the multiplier ratio is and the multiplier process. We now need to look at marginal propensities and be able to perform some calculations. So let's think about marginal propensities. It's kind of a funny word here, but what was quite important in our initial story was when we were looking at the money flowing around our economy, was this 20%. That households, every time they earned 100 million, they saved 20%. Every time they earned 80 million, they saved 20%. So this concept of how much households save for every extra bit of income is a marginal propensity to save. And marginal propensities tell us for every extra £1 of income, what do households or businesses do with it? If they spend it, that is their marginal propensity to consume. If they save it, that is their marginal propensity to save. If they pay tax, that is their marginal propensity to pay tax. If they import something, that is the marginal propensity to import. For every extra £1, how much do they spend or save or pay tax. So in this example, the marginal propensity to save is 0.2 or 20%. For every extra pound the households have earned, they've always saved 20%. And these concepts are important if we're going to understand the multiplier effect within our economy. Because what we need to understand is every time a household earns income, what happens to it? That extra income they've earned, do they consume? Do they save? Do they pay tax? Or do they import? I.e., is there more consumption going on or is there more withdrawals? If there is more consumption, the multiplier effect will be bigger. There's going to be a bigger impact on GDP. However, if the withdrawal effect is bigger for any extra income, then the multiplier effect is going to be smaller. There's going to be less of an increase in GDP. So let's first of all talk about the marginal propensity to consume. This is how much extra is spent on goods and services following an increase in income. So for example, if incomes rose by £10,000 for households, and of that £10,000 they spent £6,000, the marginal propensity to consume will be 6,000 divided by 10,000, 0.6 or 60%. So this example here, households spend 60% of any extra income that they earn. Let's now look at marginal propensity to withdraw, and we should make sure we have all these concepts and terms down in our notes. The marginal propensity to withdraw is saying of any extra income, how much is saved, taxed, or spent on imports. So for example, if incomes rose by £10,000, but people saved, either paid tax or imported £4,000, as a result, the marginal propensity to withdraw would be 0.4 or 40%. 40% of their extra income is not spent on consumption, it's actually spent on withdrawals. It's worth noting that the marginal propensity to withdraw would always be 1 minus the MPC. So for example, if we said that 60% was the marginal propensity to consume, then they must, by definition, be withdrawing the other 40%. The marginal propensity to save. How much extra is saved following an increase in income? For example, if incomes rise by £10,000 and savings increase by £1,000 as a result, the marginal propensity to save would be 0.1, 10%. People in this economy are saving 10% of every extra bit of income that they earn. The marginal propensity to tax. Again, how much extra is paid in tax following an increase in income? For example, if incomes rise by £10,000 and people pay £2,000 more in tax, or people pay tax £2,000, the marginal propensity to tax would be 0.2, 20%. People are paying 20% of any extra income. House is tax. The marginal propensity to import. How much extra is spent on imports following an increase in income? For example, if incomes rise by £10,000 and imports increase by £1,000 as a result, the marginal propensity to import would be 0.1 or 10%. People spend 10% of extra income on imports. So our marginal propensities. In our examples here, the marginal propensity to consume was 0.6. So for every extra pound people earn, they are spending on consumption, 60 pence. The marginal propensity to withdraw in our example there was 0.4. And that makes sense because if people aren't consuming, then the money must be going somewhere. It must be being withdrawn. So these two always add to 1. It's worth finally noting that the marginal propensity to withdraw in total will be the marginal propensity to save plus the marginal propensity to pay tax plus the marginal propensity to import. So in our example, the marginal propensity to save 10%, tax 20%, imports 10% added together gives us the marginal propensity to withdraw. So we're trying to say if every extra income that comes in from our initial injection, has gone round, extra income, how much of it is consumed, how much of it is withdrawn. And this is important to understand the multiplier, how much more GDP will be from the initial injection. So we can use these marginal propensity to consume percentages or figures to work out the multiplier ratio that we spoke about earlier. And there are two formulas we need to know. The first one is the multiplier formula is 1 over the marginal propensity to withdraw. So 1 divided by the marginal propensity to withdraw will give us the multiplier ratio. Remembering that the marginal propensity to withdraw equals the propensity to save, propensity to tax, plus the propensity to import. We also said that the marginal propensity to withdraw is the same as 1 minus the marginal propensity to consume. So this is an alternative way of calculating the multiplier ratio. We can take 1 and divide by 1 minus the marginal propensity to consume. Back to our example, using the multiplier formula, we know that the marginal propensity to withdraw in our example was 0.4 or 40%. So 1 divided by 0.4 equals 2.5. If we use the second formula, the marginal propensity to consume was 0.6. So the multiplier formula of 1 over 1 minus the MPC would give us a multiplier value again of 2.5. The same answer, just slightly different formulas. So what does this mean? This is our multiplier ratio. What does that mean? It means if there was an injection into the circular flow of £1 million, then national income would increase by 2.5 times that initial injection. So national income or GDP would increase by £2.5 million. What would affect the value of the multiplier? Well, an economy, the multiplier is likely to be quite high when the economy has plenty of spare capacity, so they can quickly increase output and produce more. If the propensity to import and pay tax is low, then there's going to be more consumption, so the multiplier value will be higher. If there's a high propensity to consume any extra income, then there is going to be a higher multiplier value. It's going to be a low multiplier value if the economy doesn't have any spare capacity, the output can't be increased even though people perhaps demand it. If the propensity to import is high, then there's going to be greater withdrawals, so there's going to be a lower multiplier value. If there's higher inflation, that might cause higher interest rates, which could reduce the impact of any further consumption, so real GDP might not increase by very much. In terms of government spending, when the government spends capital, or makes capital investments such as new buildings, this often results in quite a high multiplier effect. And economists have calculated that the multiplier value for developed economies like the UK tends to be around 1.5. So if governments try and boost the economy by spending, say, £100 million, there's likely to be a £150 million increase in GDP once it's circulated around the economy. For developing countries, it's estimated to be slightly higher at 1.6. So in this video, we've looked at what is meant by the multiplier ratio and the multiplier process. We've looked at marginal propensities and how they're important for calculating the multiplier ratio. And we should now be able to perform these calculations. That's it. Thank you very much.